Hello everybody, welcome to another lesson by me, Miss Pythagoras. In this lesson, I will explain calculus application more specifically with the focus on maximum or minimum rate of change problems. This is lesson 4 of 5. Have you subscribed yet? You can also visit my website onlinemaths.co.za. The link is in the comments below. There you will find all the chapters in the syllabus. Let's start with the maths. Example 1. A biologist states that when a certain type of antibacterium is introduced into a culture of bacteria, the number of bacteria present is given by the formula B of T in millions, is the number of bacteria present T time measured in hours. And then I give you the equation there. Question 1. How many bacteria were present at the beginning? So now, can you hear that there was no movement? And at the beginning means at time equals 0. So therefore, into the original equation, in T's place, you will substitute 0, and then the answer is 1,500 million. Question 2 says, at what moment was the maximum number of bacteria present? So what can you hear there? Maximum, minimum, differentiate, equate to 0. Therefore, you will take the original equation, you will find the derivative, and it becomes minus 8t plus 60 equals 0, and you solve t. The 60 walks across, we will divide by minus 8, and we will see that at time 7,5 hours, the maximum number of bacteria was present. Example 2. During an experiment, the temperature T varies with time T according to the equation, and then I give you the equation for the temperature. Number 1. Determine an expression for the rate of change of temperature with time. So the minute you hear rate of change, then you will find the derivative. Not equal to 0 because it's not the maximum rate of change or the minimum, it's just rate of change derivative. So when you derive that one, you end with 8 minus 2t. Question 2. Determine the rate at which the temperature was changing after 2 seconds. So now you know that this little equation here, the derivative, this one is the rate of change. So now into the derivative, in t's place, you will substitute 2 and you end with 4 degrees per second. Question 3. Determine the maximum temperature. So now you know maximum minimum derivative equals 0. So we have the derivative already. It was 8 minus 2t, and now we will equate to 0. And we will solve t. 8 is 2t, divide by 2, t is 4. And then the rule is every maximum minimum, every value has an original y value. So therefore, into the original t equation, you will substitute 4. So in goes 4, and you end with 60 plus 8 times 4 is 32, minus 4 squared is 16, and when you add all of that, the maximum temperature will be 76 degrees Celsius. Example 3. The depth D of water in a kettle T minutes after it starts to boil is given by D of T, and then I give you the equation where D is measured in millimeters. Number 1. How many millimeters of water are there in the kettle just before it starts to boil? So what does that mean? There's your equation, and just before it starts to boil means time is 0. So it's not the derivative since there was no movement. It was just still the depth. So in t's place you substitute 0, therefore 86 millimeters. Number 2. As the water boils, the level in the kettle drops. Find the rate at which the water level is decreasing when t equals 2. So can you hear at number 2, as the water boils, therefore there's movement. And the minute there's movement, you will find the first derivative. So the first derivative is minus an eighth minus 3 over 4t squared. Now they say find the rate when time is 2 minutes. So that equation over here, the derivative, this is the rate of movement equation. So therefore we will substitute into that one in t's place 2, and we end with minus 3 and an eighth millimeters per minute decline. And how did I know that it was a decline? Since the answer was negative. Example 4. An industrial process requires water to flow through its system as part of the cooling cycle. Water flows continuously through the system for a certain period of time. The relationship between the time t from where the water starts flowing and the rate r at which the water is flowing through the system is given by the equation r equals minus 0,2 t squared plus 10t, where t is measured in seconds. Number 1. After how long will the water be flowing at the maximum rate? So what can you hear? Maximum, minimum, derivative equals 0. So there's your equation. dr over dt, we find the derivative minus 0,4t plus 10 is 0, and we solve t. 10 is 0,4t, divide away the 0,4, therefore at 25 seconds. Question 2. After how many seconds does the water stop flowing? So what can you hear there? This is all happening at r is equal to 0, but not the derivative. This is the original equation, since the original equation was for the flowing of the water through the system. So now we will equate the original equation to 0. And we solve t. I will take out t as a common factor, and I'm left with bracket minus 0,2t plus 10. t is 0, or minus 0,2t plus 10 is 0. Let the 10 walk across, divide away the 0,2. Therefore, t is 50 seconds. Now you know everything there is to know on calculus application, more specifically rate of change. Click on the video in the right hand corner to take you straight to the next lesson. That one will be calculus of motion.